Welcome to this explainer video on server load balancer using SDN. Here, we would like to take you through challenges that are associated with deploying traditional load balancers. Traditional load balancers, commonly known as application delivery controllers, are physical appliances deployed in line with the traffic. In order to provide load balancing at line rate, these devices are realized in specialized hardware, contributing to significant spend for enterprises and telecom operators. These inline devices introduce additional latency, thereby impacting the quality of experience to latency-sensitive applications. Further, current load balancing solutions do not factor network load conditions, resulting in poor experience to the users. In order to offset the challenges associated with the deployment of traditional load balancers in terms of CapEx spend and inflexible deployment configurations, it is necessary to have a fresh look at the load balancer implementations. In this context, Tech Mahindra has developed server load balancer application leveraging HP VAN SDN controller such that no physical or virtual load balancer is required in the data path. Physical or virtual servers can be deployed without performing elaborate network planning. Further, load balancing decisions take into consideration the network conditions so as to achieve optimal utilization of the resources. Server load balancer flow steering application can reside on or outside the SDN controller, and it interacts with the SDN controller for all network configuration needs over RESTful APIs. Let us look at the high-level functionalities of the server load balancer application's TCP connection load balancing. Load balancer application initially programs the OpenFlow switches through SDN controller's RESTful APIs such that TCP SYN packets originated from the clients are received by it. As a result, when a client application initiates TCP connection to the virtual IP, TCP SYN packet is received by a load balancer application. It then allocates target server based on the configured algorithm and programs NAT functionality in the originating and terminating switches to interwork between virtual IP and the target server IP and sets up the path between the originating and destination switches. It also adds actions to divert TCP termination request packets to the load balancer application. As a result of the installed flows, normal traffic flows directly between the client and server without ever hitting the load balancer application. When a packet containing TCP termination flags is received at the application, forwarding flows are removed from the switches. The server load balancing application has an easy-to-use UI for physical server and cluster configurations. It also exposes web interface for integration with IT orchestrators for the dynamic configuration of elastic server loads. The load balancer application also supports an interface to view instantaneous load on the servers and network paths. It also supports detailed logging for performance counters and network events for offline analysis. The server load balancer application provides the following benefits. The separation of control and data planes allows load balancing functionalities to be executed over the SDN switches, not requiring additional inline devices as in the traditional networks. Customized algorithms for load balancing can be created, taking into consideration not only the load on the server, but also the performance aspects on the network like congestion, queuing delay, etc. at the intermediate switches. SDN-based load balancing concepts can easily be extended into WAN so as to maximize network utilization and provide differentiated quality of experience by taking into consideration other parameters like category of the incoming traffic and location of the originating traffic. Thank you for watching, and please visit us at www.techmahindra.com. You can also reach us at prodengineering@techmahindra.com.